I'm Emma. I work with Garnet Connections, which is a landscape partnership project that is funded by the Lottery Heritage Fund. The project is based in southwest Scotland, around the River Garnock, which runs from the Muirshiel Hills in Renfrewshire, down through Ayrshire to Irvine Bay, where it meets the sea. So on the map here, you can see the boundary of the project area and some of the towns within it. This area that surrounds the River Garnock is otherwise known as the Garnock Valley, not the Garlic Valley. Garnock Valley is rich in cultural and natural heritage, with historic settlements, a varied industrial past, and nature reserves like RSPB Loch Winnoch and the Scottish Wildlife Trust's Garnock Floods. So the overall aims of Garnet Connections is to engage with communities in the Garnock Valley and connect local people to the wealth of heritage that surrounds them, to enable the history of the area to be remembered and preserved, and the natural assets to be protected and enhanced for species biodiversity. And to do this, Garnet Connections is made up of a variety of partners with a range of knowledge and skill sets to help deliver a variety of projects, from archaeological digs to habitat restoration. So one of these projects is Garnock's Buzzing, which is being delivered in partnership with BugLife, the Scottish Wildlife Trust, and Scotland's Rural College. The Garnock's Buzzing project aims to improve habitat for pollinators across the Garnock Valley, and so far has seen wildflower meadow creation at Lochshore and Kilbirnie Public Park, for example, as well as the creation of bee banks in Barmill, Ardrossan and Irvine. Another part of Garnock's Buzzing is to deliver pollinator identification training events such as this one. So now I'll just pass you over to Lynn, who will tell you a bit about the Nectar Network project.
Great, thank you, Emma. Yeah, I'm just going to be very brief because and I want to thank Emma first of all for actually sorting out all the bookings for this. And so I'm Lynn Bates, as I said. I'm the Nectar Network Coordinator for the Scottish Wildlife Trust. This is a Scottish Wildlife Trust-led project, and the aim is to establish nectar and pollen-rich sites all the way down the Ayrshire coast. We have an area between Irvine in North Ayrshire and Girvan in South Ayrshire. And we just are trying to really connect all these areas so that for the long-term sustainability of pollinators. We're funded by Nature Scot. We have also received funding this year from the Fairway Foundations, which is actually an American-based charity, and we're also funded by the RNA, which is golf's national governing body, because we do a lot of work with golf courses. As you can imagine, if you're not from Ayrshire, you'll know. Well, if you're not from Ayrshire, you may not know, but if you are from Ayrshire, you'll know that the whole coast is full of links courses, and which is a great habitat. And we're working with a lot of those golf courses. So without further ado, I would like to hand over to Craig Nisbet, who has kindly agreed to give us this introduction to pollinator talk. Craig Nisbet is the Conservation Officer for BugLife, but I'm sure he'll explain more about what he does. So over to you, Craig.
Thank you very much for the introduction, Lynn and Emma, and good afternoon, everybody. As Lynn said, I'm Craig Nisbet. I'm the Conservation Officer for BugLife. I've been in post since September, and a major part of the role that I've been asked to play with BugLife has been delivering on a lot of community engagement projects, such as Garnock's Buzzing. And in normal times, without the pandemic that's going on, then I would have been out in the field and running training workshops and face-to-face interaction with a lot of people. But as things stand, a lot of my work over the course of the winter particularly has been taking place online. So that's why you guys are watching me on a screen today as opposed to us meeting in person. But hopefully at some point that will be possible. just to begin with, I'll give you a brief introduction to what I'm going to be telling you about today. This presentation, it's an introduction to pollinators. I've roughly divided it into 3 parts. So the first part is going to be an introduction to bug life, an introduction to pollinators, why pollinators are important, threats that are facing them, what we can do to help, and what bug life are doing to help. And then the second part of the presentation is going to be the introduction to the actual pollinators, the key groups of pollinators that we're likely to encounter in the UK. And then the third part is the really important part, the part that I'm going to be introducing you to a survey technique known as flower to insect timed count surveys, or FIT counts for short. So the third part of the talk is what I really want you to listen to, but hopefully you'll find the first and the second parts quite interesting in places as well. So a little bit about bug life first. I'm sure many of you have come across bug life before, but for those of you that haven't, we're the only organisation in Europe that are concerned with the conservation of all invertebrates. So that involves protecting, improving and expanding their habitats and strengthening the respect given to bug species. So our main aim is to halt invertebrate extinctions and achieve sustainable populations of invertebrates in the UK. So how do we do this? Well, there's various methods that we adopt. We're looking to inspire others. And like I said, that's a major part of what my role this winter has been in terms of organising a lot of these online workshops and presentations, but more generally speaking, and particularly raising awareness through community engagement activities, public events, guided walks, and online talks such as the one that I'm doing today. And I've done various talks throughout the last month or so to universities and other groups as well. We carry out various practical conservation tasks, as you can see in the top right of this slide. They're building a dam on a peat bog to retain some of the water that's on this peat bog. That's a very important aspect of peat bog conservation, and so there's a lot of dam building going on in various bogs. We have a peatland restoration officer that's focusing a great deal of her time on peatland management. So a lot of work goes on there. But another really important part of practical conservation that we carry out is wildflower meadow creation and wildflower meadow management. So that we're going to be touching a little bit on that during the course of the presentation. We're also always aiming to shape policy in whatever way we can. The 2 key groups of invertebrates that bug life focus specifically on, as you can see by these 2 documents in the bottom left of this slide, the Get Britain Buzzing Manifesto for Pollinators and a Strategy for Freshwater Invertebrates. Bug life are particularly concerned with pollinators and freshwater invertebrates, and there's a couple of reasons for that. The first is that these 2 groups of invertebrates are absolutely essential to life on Earth. As we know it. So we feel that they're the most worthy of focusing attention and shaping policy for. And the other reason is that there aren't any organizations that are focusing specifically on these particular groups. There are a wide variety of charities, invertebrate conservation charities out there, but we're trying to focus on particular groups that we deem to be particularly important to conservation. So a little bit about invertebrate services and why invertebrates are important to us. I think this first statement is a remarkable one. Over 95% of all wildlife on the planet are invertebrates. That is a remarkable statistic, and it goes some way to demonstrating how important they are on a global scale. But they provide us with a number of free services that we we depend on and quite often don't give them credit for. But the first of these, soil management and nutrient cycling. For those of you that have compost bins in your back gardens, I'm sure you'll recognize the importance of worms in terms of breaking down organic material. So they play a key role in doing that, not just in your compost bins, but out in the wild as well. Water quality. So in terms of maintaining water quality, we have filter feeders in freshwater habitats that will keep water clean, or certainly keep water cleaner than it otherwise would be. And a number of freshwater invertebrates also act as indicator species, so they can tell us whether or not the water is polluted or unpolluted, whether it's clean or dirty. Decomposers. We have a number of species, not just earthworms, but a wide variety of beetles, Coleoptera, and other invertebrates as well, that break down a lot of rotting organic material, particularly in woodland habitats. And so essentially they're nature's recyclers, and along with the fungi of the world, they play an important role in recycling a lot of rotting vegetation and rotting natural organic material. We have predatory invertebrates that often give us a service of controlling pest species. And a good example of that might be dragonflies feeding on midge and midge larvae when they're in the water, and midges when they've hatched. So there are a number of examples of predatory invertebrates. Think of spiders catching a wide variety of insects that could otherwise cause a nuisance to us and aren't necessarily man's best friend. And they also, a number of invertebrates also play a key role in a wider food chain. If you look at birds as a particularly good example of that, where I live at Loch Leven, just north of Edinburgh, every May we have a mass hatch of chironomids, of midge flies, and you see massive plumes of them over the loch. And then you have lots and lots of swifts and swallows and house martins and sand martins all coming in and feeding on this mass hatch of invertebrates. So these chironomids play a key role in the food chain of these migratory birds as they return to the UK to their breeding grounds. But it's not just birds and other wildlife that depend on invertebrates. If you look at our own dietary requirements, particularly in our own culture in the UK, we eat a lot of lobster and crab, shrimps and prawns. If you look around the world, there is a wide variety of other invertebrates that also play a key role in the diet of a number of people. And the culinary appeal of some of these might be questionable, but nevertheless they do play a key role. And finally, the invertebrate service that we're here to talk about today is pollination, arguably the most important. And the next couple of slides you'll see why. But first, I'm sure most of you already are aware of what pollination is, but when we're talking about insect pollination, this is essentially what we're talking about. Insects such as a bee will visit a flower looking for nectar, and it will collect the pollen actively in some cases, but incidentally in other cases, and often in a pollen basket. In the case of many social bees, they'll have pollen baskets to take the pollen back to their nest. Once it's visited one flower, it flies off, visits another flower, transferring the pollen from one flower to the next, and allowing that flower to reproduce as a result. So it's in this way that these flowers are able to reproduce and spread across a particular habitat, and across other habitats as well. And without this form of pollination, a number of our wildflowers and native plants wouldn't exist, couldn't survive. So it's an essential part. I'll touch on that again in a moment. But one of the most important, certainly most readily noticeable reasons why pollinators are so important is that they're essential to the growing of our own food production. And I love this statistic, this quote on the slide here: 1 out of every 3 mouthfuls. Essentially what that means is 1 out of every 3 mouthfuls is down to insect pollination. Quite how they've worked out that statistic, I'm not 100% sure, and I'm sure it's not on the money, but I think it highlights the point that pollinators are very important for the food that we depend on. And the statistics on this slide outline that point in a little more detail. 90% of the world's crop species, which equates to about 132 billion pounds of global economy per annum, which is a remarkable figure. In the UK alone, around about 500 million per annum, 13% of the agricultural revenue from the UK. So they play a significant part in food production and the global and national economy. And they also play a very important role for other wildlife. As I mentioned earlier, the pollination by insects is essential for a wide variety. In fact, 80% of the wild plants in the UK depend on insect pollination in order to survive. So it's not just the crop species that we're growing in the UK to feed ourselves that depend on these pollinating insects. It's also the wild plants that are in our country as well, in our country and across the world as well. So, and as I mentioned earlier, insects are an important food for other wildlife, not just birds, not just humans, but a wide variety of wildlife will depend on a wide variety of insects and invertebrates to feed on. So I'm not going to dwell too much on this slide, but I think it's important to understand that UK pollinators are declining. Over 250 species are threatened with extinction. That includes 6 of our 25 species of bumblebee nationally, and also a proportion of our hoverfly species, butterfly species, and moth species. So all of these groups of pollinators are experiencing declines. And there's a few reasons for that. The first reason is habitat loss. The second is the use of pesticides and herbicides. And the third is the introduction of diseases and parasites. So habitat loss is perhaps the most well understood cause of invertebrate insect declines. And I think the picture at the bottom of this slide demonstrates that very well with the growth of agriculture in our country and worldwide. Many habitats have provided a home for invertebrate populations are now becoming fragmented, and as a result, these invertebrates, these insects, aren't able to travel between the areas that they otherwise would be able to. So that's a significant problem and something that we are looking to try and address, as particularly as bug life, but also I think as a population, as a species, we really need to be trying to address habitat fragmentation, not just in the UK, but across the world. Pesticides and herbicides are a significant problem as well, and particularly the use of neonicotinoids, which are systemic pesticides. Neonicotinoids can have a seriously damaging effect on wild populations of pollinating insects to the point that they can virtually wipe them out. There was neonicotinoids have been back in the news recently because they are now banned in the UK, but the ban has been temporarily lifted to be used on sugar beet crops down south for this season only, which has caused a lot of controversy and potentially will have damaging effects on the survival of pollinating insects in the areas that they are being used. So far as I understand, I think we're safe from neonicotinoids in Scotland, but that's it's still a cause for concern that they are being used again down south. I actually attended a very interesting webinar. I don't know if anybody else caught it, that Dave Goulson was on the panel, and they also had a sugar beet farmer from down south that was also on the panel. I forget the name of the webinar, but it was very, very interesting. It was only 3 weeks ago that I think it was on, but I would recommend that if you want to know a little bit more about the use of neonicotinoids and why the ban has been temporarily lifted. The third point, the third reason that pollinators are declining are the introduction of diseases and parasites. Now, this can occur quite often when honeybees are brought in from abroad, and if parasites are brought in on those honeybees that carry particular diseases that are foreign to the UK, then wild insect populations are under threat from these introduced parasites, and they could have a detrimental effect if transmitted into wild populations, particularly of bumblebees and solitary bees in the wild. So these are the main causes for concern and the main things that we really need to try and address. What can we do in terms of helping our pollinators? As individuals, there are a couple of things that we can do, and one of them, the key thing that we can really try and do, is create more habitat for them. And this habitat can be created in any open space that we have available to us: gardens, parks, business premises, green roofs, field margins, road verges, brownfield sites, window ledge boxes. Any kind of habitat that you have available to you could be converted into an area where wildflowers are growing and consequently benefiting our wild pollinating insects. So it's important that we all recognize this fact and are all able to do what we can to create more habitat for them, however large or small that habitat might be. And the last point here, it's important that correct management is adopted. So I'll touch a little bit more on correct management and resources that are available to provide you with the information that you need in order to figure out what correct management is. But in terms of managing wildflower meadows, for example, that would be a regular regime of cutting and lifting the vegetation on an annual basis around autumn time, and otherwise leaving it to grow so that the wildflowers don't get chopped back. So what is it the Bug Life are doing? We have established an initiative called Beelines. Beelines was launched a few years ago down south, but it was only launched in Scotland officially in December 2020 when the map was finally rolled out. The primary aim of Beelines is to work with farmers, landowners, businesses and local communities across the UK to create a network of wildflower-rich habitats to provide food for pollinators, as well as making it easier for them to move around the country in response to climate change and other environmental factors. Essentially, what we're looking at doing is creating pollinator highways across the country that pollinating insects can use to move around more freely without being so isolated. So what we're trying to address first and foremost with Beelines is the habitat fragmentation issue that our invertebrates are facing, our pollinating insects are facing. So the guiding principles behind Beelines essentially are they're 3 kilometre wide habitat enriched zones linking together the best wildlife areas. Ideally, the aspiration of the Beelines initiative is to create these continuous lines of habitat so that pollinators can move around freely. We're looking to expand wildlife sites that exist, and we're looking to create new sites as stepping stones between the existing wildlife sites that are already there. So where continuous lines of habitat aren't achievable or aren't practical, then we want to create as many stepping stones as possible so that we give the pollinating insects the best chance possible of moving around. Within Beelines, we're looking at creating a diversity of habitat types and structure, and we're also looking at connecting semi-natural and other habitat features. So that could include things like rivers and forests and woodlands, as well as habitats within urban environments, gardens, parks, and farmlands, hedgerows, that kind of thing as well. So we're looking at connecting all kinds of different habitats together so that wherever pollinators might find themselves, there are always options for them to continue moving around. This is going to involve a great deal of coordination and collaborative work, and we are working with, I think, over 60 partners so far. have become involved in the Beelines initiative in one way or another nationally, and the number of partners that we're collaborating with are expanding quite rapidly. So the more people get involved with Beelines, the better. And the main aim, what we're looking to achieve, is to provide habitat for insect pollinators and other wildlife across the country. So these are the maps. As I said, the Scotland Beelines map was only officially launched in December of last year, and that now completes the Beelines network across the UK. As I said, this is an aspiration at present. These lines are literally lines on maps. They aren't currently pollinator highways, but the idea is that we're looking to encourage as many people as possible that find themselves situated on one of these Beelines to take part and to either establish a project that as a result of being inspired by the Beelines initiative, or to report a project that they already are involved in or are aware of that is situated on the Beeline, on a Beeline, with a view to allowing bug life to connect all of these projects and connect all of the efforts that are going on to benefit pollinators nationally. So essentially what we're looking at doing is creating these highways to allow pollinators to move more freely across the country. The maps themselves are interactive, and on the website there are plenty of resources that are available to download. The maps are downloadable as well, but by saying that they're interactive, what I mean is that you're able to zoom in to the maps and have a look closely at your particular area to see whether or not you actually fall onto a Beeline. And if you do, then through the website, there are ways that you can register the project that you're involved in or the project that you wish to start up, and explain a little bit more about the work that's going on in terms of efforts to benefit pollinators in your area. So it's all fairly self-explanatory on the website, and there are plenty of resources as well there that will allow you to look for any inspiration that you need, or any assistance or advice that you might need in order to figure out what the best ways for you to help benefit pollinators in your area might be. So it's well worth checking out. I've got a short list of resources at the end of the presentation that I'm quite happy to circulate to everybody that's in attendance today. I can either do that directly, or I can pass that on to Emma, and she can perhaps circulate it to everybody that's been here, so that you've got access to this website as well as a number of others that I'm going to refer to in the presentation. Okay, so that's the end of the first part of my talk. And now we're going to move on to the introduction of all of our UK pollinators, the insect pollinators. These are the key groups that I'm going to focus on today, and I'm going to be introducing you to them. But firstly, it's worth pointing out there's at least 4,000 species of pollinating insect in the UK. And I'm not going to cover all 4,000 of them. You don't need to know all 4,000 of them either. I would suggest that very few people do. But what you will need to know in terms of conducting these fit counts that I'm going to introduce you to later in the presentation, I'm hopefully going to cover in the second part of this presentation. And all of these insects, all of these groups of insects will be covered within the fit counts. So the groups that we're going to be particularly concerned with today, primarily bees, because they play the most significant role in pollination throughout most of the country. Bees and wasps are both part of the order Hymenoptera. Beetles form the order Coleoptera, and they also contribute to pollination. We also have true flies, which includes the group of hoverflies, and they belong to the order Diptera, and butterflies and moths, which both combine to make up the order Lepidoptera. So these four orders of insects are the primary groups of pollinators that we're going to be focusing on. There are others, but these form the majority of those 4,000 species that pollinate plants and crops in the UK. So I'm going to start with the Hymenoptera, which include the wasps and the bees. We have 9 species of social wasp, 12 25 species of bumblebee, and about 250 species of solitary bee. The majority of our pollinating hymenopterans, the pollinating bees, are solitary bees, and the diversity in solitary bees is quite extensive. We'll look in a little bit more detail into that in a moment. And the one species of honeybee as well, which I'm going to touch on briefly. But firstly, I'll start with the ones that you guys are probably most familiar with, and I'm sure you'll all have encountered some, if not all, of these bumblebees at some stage, either in your back gardens or being out in the field. These are what are known as the big six, the 6 bumblebees that you're most likely to encounter anywhere in the UK: the buff-tailed, white-tailed, early, red-tailed, common carder, and garden bumblebee. So I'm sure most of you are already familiar with these guys, but for the purposes of a fit count, all you need to record them as is a bumblebee. So as long as you know that this is a bumblebee, you're a step in the right direction towards your fit count identification skills. Another bumblebee that's of particular interest in the UK and indeed in Scotland is the tree bumblebee, which only arrived in the UK in 2001 and only arrived in Scotland in 2013, I believe was the first date that these were recorded. They're now quite common in the central belt of Scotland and have been progressively moving north since they arrived in the UK in 2001. So it's thought that they're an indicator species of a warming climate. And there are other insects that have been associated with a warming climate, and as a result have been moving further north. But tree bumblebees, Bombus hypnorum, are one of the indicator species that we have within the Hymenopteran order. And quite easy to identify as well, with that ginger thorax and the black abdomen with the white tips. So well worth looking out for if you've not encountered them before. But I would suggest that they are most likely in the Garnock area now. So worth looking out for. And this slide shows you photographic images of many of the more common bumblebees that we're likely to encounter, particularly in the central belt and south of Scotland. And one thing that most bumblebees do have in common is what's indicated in the bottom right picture here, a pollen basket, which is on the tibia of the rear leg. The pollen basket, bumblebees have a pollen basket to collect pollen, as the name would suggest. And the reason that they're doing that is that they're taking the pollen back to their nests to feed their larvae. So this pollen basket is a key feature that helps you identify whether or not it's a bumblebee, and it's particularly obvious if it's got lots of pollen in it, but you can quite often see it when it's not laden with pollen as well. So these species should be relatively familiar to you: the garden bumblebee, Bombus hortorum, common carder, buff-tailed bee over there. There's the tree bumblebee that I talked about in the last slide, one to look out for. This species, the Blaeberry bee, Bombus monticola, doesn't feature in the slide of the big 6 bumblebees because it's not because it's only 6 rather than big 7, but it's also not readily you won't encounter it in many parts of the UK. Some parts of the UK it can be particularly common, and we do get Bombus monticola quite frequently at Loch Leven on the hillsides, and they're closely associated with Blaeberry, heather, upland, moorland habitats. So many parts of Scotland have reasonable populations of Blaeberry bee, but the further south you get, the fewer Blaeberry bees you're likely to encounter. And the red-tailed bee here in the bottom right was the one that was modelling the pollen basket quite well there as well. So these are some of the more common bumblebees, but they're not the only kind of bumblebees. There's also 6 species of cuckoo bumblebee that also fall under the same genus of Bombus, but are slightly different from the rest of the bumblebees. And you can identify them by looking at their hind legs. They'll lack a pollen basket. The reason they're cuckoo bumblebees is because they're known to be kleptoparasitic, which means that they'll be looking for host species nest. So one of the other bumblebees that actually nests and has worker bees that are looking after the larvae and a queen bee that's laying all the eggs. The female cuckoo bumblebee will look for the nest of the host species, invade that nest, subdue the queen bee of that particular species, lay the cuckoo bumblebee eggs within all the cells, within all the egg cells of that nest, and then have the worker bees raise her eggs and her larvae rather than their own species. So it's quite a sneaky strategy, but it also means in the cuckoo bumblebees there are no workers. There are only females and males, so that all of the females will be looking to invade a particular nest of a host species of bumblebee. So they are still classed as bumblebee in the same genus, but they're a little bit different from the others. And as you can see, this is the pollen basket that I was referring to there, that is readily visible in the regular bumblebees, but is lacking in the cuckoo bumblebee. So moving on to honeybees, which are also social bees, in fact, highly social bees. They're not actually native. They've been domesticated and they're often kept in hives. And the reason for this, as their name might suggest, is for their production of honey, their exceptional production of honey. And whilst other social bees will produce honey, they don't produce enough honey to harvest for us. So we've taken honeybees and have now manipulated them to produce enough honey for us to harvest, which is a fantastic resource for us. But a couple of things about honeybees: they're not as efficient at pollinating as bumblebees are, and I think part of the reason for that is that they're a little bit pickier in terms of which flowers they'll visit and which flowers they'll subsequently pollinate. They've got a very distinctive appearance and are quite readily identifiable. There are a couple of solitary bees that could be confused for honeybees, but we'll look in a little bit more detail at the distinguishing features between them in a moment. But social bee life cycle is what I'm going to touch on next. The social bees include the honeybees and the bumblebees. The hives or nests that you can see in the pictures here show very different nesting strategies, but essentially they're doing the same thing. They're working cooperatively as one unit, as a hive. And in both honeybees and most species of bumblebee, they'll have a queen bee and many female worker bees, keeping the hive structure going and looking after the eggs and the larvae until they're ready to leave the nests. In the case of honeybees, you might have as many as 60,000 workers in one hive. It's an exceptional number of bees for one particular hive, and that's part of the reason why so much honey is produced. But in the case of bumblebees, they tend to be much smaller nests in wild habitats, places like hedge banks and under rocks, or even underground in underground holes and dense grass tussocks. But essentially they're making a similar kind of nest, but a much more scruffy looking arrangement, and with far fewer workers. Somewhere in the region of 50 to 200 worker bees will be looking after that nest and assisting the queen in rearing her eggs and larvae. So similar kind of strategy, but achieved in very different ways. The other life cycle of many of our bees, and the majority of the bees that we have in the majority of the species that we have in the UK, the solitary bees, have a very different lifestyle, very different approach to breeding, and that is that they nest alone, as the name solitary bee would suggest. They don't collaborate in the same way that the social bumblebees and honeybees do. So one female will be laying her own eggs and raising her own larvae, feeding and raising her own larvae. Whilst they don't collaborate, they do often nest in aggregation. So they can often nest communally, and in habitats such as this one in the right-hand side here, where you've got open, sandy or muddy south-facing banks. They can quite often have many holes in one particular area. I came across a colony of plasterer bees in Handa, which was an island I worked on north of Ullapool, and there was a mass of holes, several hundred holes on a south-facing side of one of the sand dunes there. So whilst they're not collaborating, they are nesting colonially because they found an ideal habitat that suits them in terms of the right environment, the right climate for them to nest in. And also bee hotels are another good example of how they may nest communally. And as you can see the picture here of this very well produced bee hotel, will often have a number of solitary bees nesting in it together. Now they're not collaborating, but they are nesting communally. And here's an example of a solitary bee that's excavating its burrow. And another example of a solitary bee, the gold-fringed mason bee, which is a snail shell nester, quite a unique strategy amongst solitary bees, and one that's quite interesting, worth including. But what this particular species of solitary bee does is it buries the snail shell that it's chosen and then lays its eggs inside there. And as I'm sure you realize from the size of that snail shell, there's not much room for more than one bee and her eggs in there. So that's very much a solitary strategy that she adopts. So in summary, for UK bee diversity, we've got 6 different families that occur in the UK, and if you have a look down to the bottom of that list of families, the Apidae, 76 species of Apidae includes 1 species of honeybee, and this says 24 species of bumblebee because they've not taken into account another species of bumblebee that's been introduced to the UK. So within the Apidae family, that's where you'll find all the social bees, and the rest of them, the other 5 families, all comprise of the solitary bees, the solitary bee families. So that's where the majority of our bee diversity nationally comes from. And of the 250 species that occur in the UK, about 115 species occur in Scotland, although 4 are thought to be extinct and 2 have insufficient data to be sure. So you know, we're looking at just under half of the species that occur in the UK we will actually find in Scotland. So there's quite a wide diversity, and when you look at the some examples of the solitary bees, you can see the variety that can occur. These are all bees and all have some common distinguishing features that we're going to look at in a moment, but this slide indicates the diversity of solitary bees. Particularly, some of them are readily identifiable, like the tawny mining bee in the top right there, the Colitis bees, the plasterer bees. These are the ones that we similar to the ones that we had on Handa, whereas some of them, the yellow-faced bees, for example, the one in the top center, many of these you'll need to you sometimes need to dissect and use a microscope to identify with any certainty. So identifying solitary bees, even for experts down to species level, can be very tricky. So that's not what we're looking for when we're encouraging people to conduct fit counts, and that'll become more evident in a moment. So this is the first of a few slides that I've lifted from the UK Pollinator Monitoring Scheme website, and on their website there is a download guide. I don't know how well you can see my camera, but I'm going to share a link to this document anyway. I've printed it out as a handy little booklet for myself to take into the field, but the title is the Insect Groups Identification Guide, which is downloadable on the UK Pollinator Monitoring Scheme website, and that features these pages that I'm sharing on the PowerPoint at the moment. But I would draw your attention initially to the fit count category box at the bottom. This indicates what you need to identify down to. So you need to be able to tell us whether it's a bumblebee or a solitary bee. You don't need to go any further than that. And when you consider that the solitary bees are somewhere in the region of 250 species, that's saving you a great deal of effort, just allowing you to identify it as a solitary bee and leaving it at that. Bumblebees you can quite often identify to species level, but you don't need to. We're just looking to know that you've got a bumblebee visiting your flower. So a couple of key differences between bumblebees and solitary bees that are worth pointing out at this stage. As you can see in the picture here, the antennae of bumblebees are often angled or elbowed, whereas on solitary bees, they tend to be straight, sticking straight upwards. So that's a key feature to look out for, as well as the size. Bumblebees tend to be larger than solitary bees, particularly in the case of queen bumblebees. It's not always the case. If you've got worker bumblebees, they can be more easily confused with solitary bees. But bumblebees tend to be hairier and they tend to be rounder, a kind of globular shape. So these key sort of structural differences are always worth considering, and bear in mind that it's a general. These are general rules that we're looking at in terms of giving you tools to confidently identify a bumblebee from a solitary bee. We're not looking for species level at all, but also the color variations in bumblebees tends to be a more simple, more striking bands that are visible. Obviously, common carders are all ginger, but the color combinations of most bumblebees are fairly obvious with thick bands, whereas you have much smaller, often more subtle, subdued bands and color patterns on solitary bees. So they're not always as obviously marked as many of our bumblebees are. So moving on to the next group of Hymenoptera before we move on to the next order, the wasps. So within our wasps, we have our social wasps, the common wasp up there that's well laden with pollen, this picture. So excellent demonstration of how important they are as pollinators, and the hornet there as well, which is also an important pollinator. And then we have our social wasps, which comprise of over 150 species nationally. So like with our bees, it's the solitary wasps that make up the majority of wasp species in the UK and can be much trickier to identify than the social wasps. But firstly, we're going to look at the fit count categories again, another page from the Insect Groups Identification Guide from the UK Pollinator Monitoring Scheme website. And again, have a look at the fit count category. We're looking at a honeybee and a wasp here. So these are two more categories that it's important that you know. If you can identify the honeybee or identify it as a wasp, it's not even a social wasp or a solitary wasp. You just need to know if it's a wasp. The key differences to look out for here between honeybees and wasps are the fact that most bees are hairier than wasps, and that's obvious in this picture. I mean, you can still see that this wasp is slightly hairy, but not as hairy as the honeybee, and certainly not as hairy as any of the bumblebees. This was an interesting fact that it's only just been brought to my attention as well as I've been delivering this presentation, but wasps often curl their wings up when they're at rest. And you can see that in this picture here, whereas the honeybee, when it's landed on this flower, it's holding its wings flat. So if the wings are rolled up like this wasp is doing, then that's another key feature to look out for. And also the pollen basket. Obviously, honeybees and and bumblebees you'll be able to see a pollen basket which is often laden with pollen to take back to their hive or their nest. So wasps will never have a pollen basket. So a couple of important features to look out for. This slide here is a little bit more tricky, and the fit count categories here that we're looking at are solitary bee and wasp. Again, it's not solitary wasp, it is just wasp. So this comes under the same category as our common wasps or our social wasps. And a couple of key differences to look for here. The first and perhaps most apparent on the wasp picture is the size of the head, much bulkier and much more rectangular than any solitary bees. So if you have a very large headed small insect like this, then that's always a good indication that you've possibly got a wasp. Many solitary wasps won't have any hairs on them at all, and so again, it's a case of remembering that most bees are hairy, most wasps aren't hairy, and that's a useful distinguishing feature. And again, the pollen basket is sometimes readily visible, whereas wasps will never have that. Okay, so I'm moving on now from the Hymenoptera and onto Diptera, a very diverse order of insects. Over I think 7,200 species in the UK, and still growing. The number of species of Diptera is increasing globally and nationally all the time. Currently, we have 107 families recorded in the UK. The name Diptera goes a long way to providing a clue as to one key identification feature. They only have two wings, one pair of wings. The hind wings on Diptera, on true flies, have evolved into flight balancing organs called halteres, and this assists in their excellent aerobatic ability, their agility in the air, and they are much more agile than any other flying insects, and that's because they've got these flight balancing organs which enables them to hover very efficiently when you consider hoverflies, which are a key family within the order Diptera. They are very important pollinators, particularly in Scotland, because many of the habitats that they pollinate the flowers and plants in are habitats that many of the Hymenoptera, the bees, are less able to access, and as a result, the flies fill the invertebrate service, if you like, the ecological service of pollinating the plants that other insects aren't able to get to. So very important pollinators, particularly in Scotland, but all over the country. And the key group of pollinators within the Diptera, the order Diptera, are, as I said, the hoverflies. And hoverflies can be a little bit awkward because they're well known for their mimicry and will often mimic particular species of Hymenoptera in order to avoid predation. So if they look more threatening, if they look less appealing to predators, then they should be able to continue on their way, despite not being nearly so threatening as many of the Hymenoptera can be. So as you can see here, all four of these species are hoverflies, but we've got one that looks like a bee, and one that looks like a wasp, one that looks like a hornet, and another that looks like a wasp. But they all have key Diptera features that we're going to look at just now. And firstly, we're going to compare a hoverfly to a solitary bee. And the first thing to look for here is the size of the antennae. Bees will always have long antennae. If you remember back to comparing the social bees to solitary bees, the bumblebees, solitary bees rather, we had the elbowed antennae on the bumblebees and the straight antennae on the solitary bees. on a Diptera, on a hoverfly, they have short, so this is characteristic of Diptera, of the order Diptera, is that they have short, stubby antennae, much smaller than any Hymenoptera. So that's a key feature to look out for, and usually pretty obvious if you see the insect landing. The large eyes of Diptera will often give them away as well before any other feature is readily visible, but the large eyes are very obvious in hoverflies, and in fact they help you sex them as well. I think I'm right. I think I've got this the right way around, that the eyes are joined together like this one in the picture here. They're joined together, so that tells you that this is a female. The eyes are separated, so not joining in the middle. That tells you that you've got a male. But in any case, in both males and females, the eyes are particularly large, much larger than any of the Hymenoptera eyes might be. And look at the wings as well, often very difficult to see, particularly on smaller insects that aren't sitting still for long enough for you to get a good look at the wings. But if they do land, then take a look at the wings of a hoverfly, and you'll see that they only have one pair, whereas all the Hymenoptera will have a second pair of wings. Their hind wings will be visible underneath their front wings as well. So that's a key feature to look out for. And put them all together and you can be pretty sure that you're looking at a true fly rather than a Hymenoptera, a solitary bee. But there's another feature that's worth looking out for with hoverflies, and there's a clue in the name, is their the way that they're flying. So if you're looking at a patch of flowers and you've got a flying insect that's flying in a characteristically hovering manner around the flowers, then you can be pretty sure that that's a hoverfly before it's even landed. And the hoverflies can fly in a way that Hymenoptera can't. So it's worth looking out for first and foremost before you even start looking at the morphological features. So this slide here depicts some of the trickier hoverflies. It goes to show that they're not always as obvious as the marmalade fly here on the right hand side, but these guys all fall into the same category of, I think the category is hoverfly, but it might just be fly. So we'll look at that in a moment, but as long as you can identify this as a hoverfly, you're laughing. And again, you're looking at the same key features as were depicted in the previous slide. So you've only got one pair of wings, not always going to be very easily seen on smaller hoverflies, but you have very short antennae, which I think is readily available if you get a good look, readily visible. If you get a good look at any of these insects, then you'll see that they've got short, stubby antennae and very large eyes, which will help you determine quite quickly that they are dipterans. And also look for the flying style. If they're hovering, then that should suggest to you that you might be looking at a hoverfly rather than any kind of solitary bee or solitary wasp. Okay. Moving on to the next order of insects, the Lepidoptera, perhaps the most recorded of all our pollinators, despite not contributing quite as much in terms of pollination as certainly as the Hymenopterans and the Dipterans do. If you want a little bit more information about the pollination of Lepidoptera, the importance of pollination of Lepidoptera, then there's a presentation that I organised with Butterfly Conservation Member of Staff Tom Prescott before Christmas. That presentation is now available online on the Bug Life YouTube channel, and it's well worth watching if you want a summary of some of the research that's gone into investigating the importance of Lepidoptera as pollinators. But by way of a brief summary, we've got 2,500 species of Lepidoptera in the UK, of which only 59 are butterflies, the rest being moths. The larvae, or the caterpillars, will feed on plants, and many are species specific. So a good example of that is the oak tree, for example, that plays host to a variety of different species of Lepidoptera in their larval form. The adults will generally, adult butterflies particularly, and many species of moth, will generally drink nectar and therefore visit particular flowers. And as a result of drinking the nectar, they will quite often incidentally be collecting particles of pollen and transferring those pollen particles to other flowers. How efficient this pollination strategy is debatable, is open for debate, and that's part of what Tom was discussing in his presentation, which is now on YouTube. But they do contribute to a certain extent, and it is recognised in some species more than others. Light trapping is one particular technique that can be useful in terms of recording night-flying moth species, and this can often be used as a tool for recording pollinators. So if you find moths in your moth trap that have got pollen on them, then you can take samples. Scientists have taken samples of the pollen that's on the moths that they've trapped, and then identified what pollen these moths have been carrying around, and by doing so they've been able to establish whether these moths are actually contributing to the pollination of particular flowers. So it's quite an interesting bit of research that's been done by using moth trapping as a technique. This slide here highlights some of the more common pollinating Lepidopteras that we might encounter during the day. If we were conducting our fit counts out in the field, as we would be during the day, we might encounter any one of these. So firstly, we've got the treble bar moth, the six-spot burnet moth, latticed heath moth, small copper butterfly, peacock, and meadow brown butterfly. And just whilst I've got this slide open, I think it's quite a useful slide to talk about the difference between butterflies and moths, because that was a question I was asked in a recent presentation I gave, and the example that I used, some key features between butterflies and moths. Very difficult to categorically define the differences between butterflies and moths, but generally speaking, moths don't have clubbed antennae and butterflies do. Butterflies always fly during the day, never fly at night, whereas some moths will fly during the day and night. Some moths fly during the day, some moths fly during the night. So the key features of butterflies would include clubbed antennae, fly during the day, and often rest with their wings closed. As we all know with butterflies, that's not always the case. And as we also know with moths, that's not always the case. Moths often rest with their wings open, but occasionally some species will always rest with their wings closed, making them very difficult to identify. But the six-spot burnet moth on this slide here is one of the moths that bucks the trend of clubbed antennae, as I think you can see quite well in this picture. It does look like those antennae are slightly clubbed, but it is still categorized as a moth. So the fundamental differences are hazy, and if you speak to some lepidopterists, they will say there's no defining difference between butterflies and moths. They're all part of the order Lepidoptera, and divided into separate families within that order. So moving on to the next order, the last order of pollinating insects that I'm going to cover, and the largest order of insects, in fact the largest order of organisms on the planet, are Coleoptera, the beetles. And of the beetles, we have 4,000 species that occur, approximately 4,000 species that occur in the UK. I think there's somewhere in the region of 400,000 species of beetle identified worldwide. And like I say, that's the largest order of organisms in the world. So it's a remarkably diverse group of creatures. They're not as efficient at pollinating as the other three orders, and the pollination that they'll assist with is incidental rather than deliberate in terms of the amount of pollen that they're collecting and how they're transferring it. But they often feed on the pollen that they're looking for, and in doing so, they might get bits of pollen stuck to them and then transfer it in that way when they visit the next flower that they're feeding from. So something that's characteristic of Coleoptera is that they've got the hardened forewings, creating an outer case, an outer protective shell, if you like. And the hind wings are the flight wings, if they are present. Some Coleoptera won't. Some Coleoptera will have the forewings fused, so they won't actually be able to fly at all. But if you think in the case of ladybirds, are a very good example of flying Coleoptera, will open their outer case and their flight wings will be underneath. But because they're using their hind wings only to fly with, they're much less agile in the air, particularly if you compare them to the Diptera, which are using their forewings only to fly with and are much more agile because they have the halteres, the balancing organs that have evolved from the hind wings. So important to recognize that Coleoptera do play their part, and it's important that you can identify one of these if you encounter one, and it's that outer shell that's the key feature of Coleoptera that you need to be looking for. So these are some of the main beetles that are likely: the flower beetle, soldier beetle, and pollen beetle. They're the ones that you're likely to encounter whilst doing fit counts and whilst watching flowers. So these are the ones that you need to be most aware of, most familiar with, in order to put them in the category. The fit count category, again, is just beetle. It's not flower beetle, soldier beetle, or pollen beetle. So keeping it as simple as possible for you. So that's the end of part 2 of my presentation. We've covered the 4 key groups or orders of pollinating insects, and they comprise most of the pollinating insects that you're going to encounter in the UK. So the third and final part, as I mentioned at the beginning, is introducing you to flower to insect timed counts. These are part of the UK Pollinator Monitoring Scheme, which is run by the Centre for Ecology and Hydrology. The list of resources that I'm going to provide you with will include a link to this website, which has plenty of resources, all the resources that you're going to need in order to conduct the fit counts. And if you forget everything that I've told you in this presentation today, I'd rather you didn't. I hope that you've taken some of it on board, but despite everything that I've told you today, I've gone into far more detail than is necessary for the fit counts. But there are a couple of training videos on YouTube that you can access through this website that I'll indicate to you in a moment, that if you watch them, then fit counts are essentially activities that you can do, you can train yourself to do in a relatively short space of time, and you'll get confident at doing it quite quickly as well. So essentially what they're doing is they're collecting data to establish how insect pollinators and pollinator populations are changing across the UK. This helps us to understand the extent of declines and their causes, and it's very, very simple. So like I said, all the resources and information that you need is on the UK Pollinator Monitoring Scheme website, and I'm going to direct you to that in a moment. But essentially all you need to do is you need to sit and watch a patch of flowers for 10 minutes, count all the pollinators that land on the flowers, and then record them on a recording form and input that data onto a database. It's as simple as that, and it's something that anybody with a passing interest in insects will be able to do with a little bit of practice and a little bit of prior research. So firstly, when can the counts be done? Anytime between April and September, ideally when it's warm and sunny. Must be at least 15 degrees if cloudy, 13 degrees if sunny. I know that's asking a lot being in Scotland, particularly in April, but these are ideally the ideal conditions. You know, you can conduct them in suboptimal conditions, and you'll find that you get far fewer pollinating insects visiting your flowers. So these are the recommendations that the UK Pollinator Monitoring Scheme are providing us with. Ideally, still conditions are better than windy days. So a little bit more detail on what still as opposed to windy conditions might look like are in the YouTube training videos that are accessible through the POMS website. So also worth watching for them. But It's useful to repeat the fit count that you've done at the same location throughout the year, whether that's weekly or monthly or fortnightly, however frequently you want to do the fit counts. Bear in mind, as I said, they take 10 minutes and then another 10 minutes of inputting your data and you're done. It doesn't take much time out of your day to conduct one of these fit counts. So if you choose a patch either in your garden, you can choose a patch of flowers, and then when those flowers stop and another patch of flowers starts emerging, you can move on to the next patch of flowers within your garden. And so, by doing so, you can work your way around your garden. Depends on your garden, of course. You might need to go out into a local park or a local hedgerow somewhere where you know that there's plenty of flowers to record. But there are a number of areas that you can conduct your fit counts, and as this slide indicates, anywhere with flowers will do: gardens, parks, meadows, countryside, etc. Common native plants known for their attractiveness to pollinators are the best to use. There's 14 target flower species that have been suggested by the UK Pollinator Monitoring Scheme. So ideally, you want to be aiming for one of these 14, or for one or some of these 14 target flower species, and you have to be able to identify them or get them identified if you're not able to. And you can do that by taking photographs of them and running them past people that might know, or checking some field guides yourselves. So some of the flowers that are included in the 14 target flower species are buttercups, dandelions, hawthorn, white dead nettle, knapweeds and clovers, many, if not all of which I'm sure most of you will already be familiar with. There are a number of other species as well. You can use other flowers as long as you can identify and record what the flowers are that feature within your fit count. And the last point here, it's ideal to carry out the count somewhere with a large number of your chosen flowers. So you want lots of flowers either within your quadrat or around your quadrat, so that you know that there's going to be some pollinators in the area and you're going to have some pollinators to record. But also with that in mind, bear in mind that a 0 is valid data in the same way that 100 pollinators might be valid data. So don't be too disheartened if you don't record any pollinators, particularly in suboptimal conditions. So if you've got a bit of a breeze, or if it's not quite warm enough yet, then it's always worth taking into account. But you'll stand a much better chance of recording pollinators if you're trying to record pollinators around flowers that are being pollinated by the insects themselves. So what do you need to know? As I said, those 2 YouTube training videos are on this slide, but what I'm going to do is I'm going to share these links to these particular videos, which are also available on the Pollinator Monitoring Scheme website. I'm going to include, I've prepared a list of resources that I'm going to send to Emma and hopefully and Lynn, and hopefully they'll be able to pass these lists on for you guys. But going back to what I said earlier, if you forget everything that I've said and you simply read the UK Pollinator Monitoring Scheme guidance on their website and watch these 2 videos. I think the first video is an introduction to fit counts, and that lasts about 3 minutes. And the second video is an introduction to the different groups of insects that are used, and that lasts about 8 minutes. So, the talk that I'm taking about an hour to deliver, they managed to summarize the key information for these fit counts in 11 minutes. So the fit count categories, as can be seen in the middle of this slide here, and many of which we've just covered in the identification section: bumblebees, solitary bees, honeybees, wasps, hoverflies, other flies, beetles, butterflies and moths, small insects and other insects. Those last 2 categories, small insects and other insects. Other insects, if you're sure it's not one of the other categories, and small insects if you think it might be one of those other categories but you're not sure which one. So you do have the alternative. If you see an insect, we want to know that you've seen an insect. If you put small insect, then it could be any of these categories or something else. If it's an other insect, then it's not falling into one of these categories, and that simply tells us that there is an insect pollinating that flower, but it wasn't readily identified as one of these categories at all. Oh, excuse me a moment. So what are you going to need in order to conduct your fit counts? You need a quadrat. I particularly like the homemade quadrat that's been created here out of gaffer tape, and it's particularly easy to do. It's going to be 50 centimeters by 50 centimeters. In order to do that with duct tape or gaffer tape, you would measure 54 centimeter long sections, fold it in on itself to make it non-sticky, and then fold the ends over and then wrap the ends up with an extra bit of gaffer tape. It's a very simple strategy for making a 50 by 50 centimeter quadrat. You can also make it out of wooden canes from your garden, use string. The reason the gaffer tape quadrat here is quite useful is because it's flexible, so you're not going to damage any of the flowers that you're throwing it over, and we don't want to have a really solid wooden frame that we're going to crush all the plants that we chuck it on. So you're going to need a quadrat. You're going to need a suitable patch of flowers that feature some of the 14 target flower species preferably, and you're also going to need some of these resources. You're going to need a fit count field recording form, one of which I've printed out here. It's just 2 sides of A4. You'll need one of these each time you conduct a fit count. So you'll need your recording form, you need your guidance notes. Now, I've printed the insect groups out in a small booklet form for myself, but if you don't want to print it out in order to save paper, then you might want to save it onto your phone. Like I said, these resources are downloadable, so if you just save it to your phone, then you'll have that identification guide and the identification guide for the flowers saved on your phone, and you'll be able to refer to that if you're not sure of anything while you're in the field. And they're all available to download on the Pollinator Monitoring Scheme website. So again, that's another link that I'm going to include in the list of resources I'm going to share with you. You're then going to need, once you've conducted your fit count, filled in all the data on your field recording form, you're going to need to keep it safe, get it home and record it on iRecord. For those of you that are familiar with iRecord, I'm sure you're probably using it as an app on your mobile phones, and it's an excellent tool for using in the field because you're able to record sightings that you've had during a field visit anywhere. Through the iRecord app, you can put in a species that you've seen at the time in situ, and then that's it recorded. You don't need to remember it anymore. So it's an excellent tool, but for the purposes of conducting and recording your fit counts, you need to take your recording form back to your laptop or PC, and you need to open the iRecord website through on the iRecord online form by following the link that is available through the UK Pollinator Monitoring Scheme website. So that link is on this presentation, but I'm also going to share a link to it for you. And in order to, it's a very simple form to fill in, but you'll need to have an iRecord account in order to record your fit count data. If you've got the iRecord app on your phone, then you will already have an iRecord account. And you can use the same login details that you used to register with the iRecord app on your phone in order to log on and fill in your fit count data through the online form here. If you don't have that, then you can set up a new account. If you don't have the app on your phone, then you can set up a new account and fill in the online forms that way. So important that you do that. This map here, this slide demonstrates where the fit count surveys were recorded in 2019, I believe this was. I don't think this was 2020. I think the aspiration was for 2020 to reach 1,000 counts, and I don't think they achieved that last year because of lockdown and because many people weren't out and about as they had otherwise planned. there are some significant gaps in Scotland, as you can see, and particularly in your area as well, in the southwest, in the Garnock area. The more dots that we can get on the map, the better it will be for for the overall understanding of how pollinators are doing nationally. And there's a large gap in the northwest of Scotland as well. But one of the great things about fit counts is that it's an excellent citizen science project. It's something that everybody can do, everybody can train themselves to do. And if you guys, hopefully I've given you enough information today that will make you feel confident enough to go out or go back to your computers, have a look at the Pollinator Monitoring Scheme website and think, yeah, I could do that myself. But once you've done one or two fit counts yourselves, once you've done a fit count survey or two and then submitted the data, and you realize how easy it'll be, how easy it is, spread the word. Tell your friends, tell your family, take somebody along with you. Obviously, travel restrictions being taken into account where necessary, but hopefully all of that will be a thing of the past in not too long. But if you are able to take people out and show them what you're doing, then hopefully you'll be able to encourage other people to visit the Pollinator Monitoring Scheme website themselves and give it a go themselves by downloading the resources that are necessary and teaching themselves how to do this. It's a great opportunity for people to contribute to ongoing biological recording and to sharpen their own ID skills, and also a great opportunity for people to spend a little bit of time outdoors in nature, which, as I'm sure you're all aware, is very good for the soul and very good for ourselves as individuals. So that's just about all I've got to say for now, and I would just like to encourage you all to find the confidence, feel confident to get out there and give it a go yourselves. Fit counts really are very easy to conduct. I know that Lynn has been talking about incorporating them into some of the monitoring work that she's got going on in some of the wildflower meadows in the Garnock area. So that's great to hear, and hopefully a few of you will now feel confident enough to start conducting some fit counts for yourselves. But like I said, all the information is available on the UK Pollinator Monitoring Scheme website. So everything that you need to know, everything that I've told you today is already there online, and you should be able to pick it up without too much difficulty. Like I said, those YouTube videos are very much very well worth watching, and if you're planning on going out and doing a fit count, spend 10 minutes watching YouTube before you do that, because those videos will make you feel very much empowered and prepared to go out and give it a shot yourselves.